Welcome back to Linuxprepper Podcast. I'm the host, James. Show about self-hosting, FOSS, curious sysadmins, home lab enthusiasts, people who want to DIY things themselves or just try self-hosting their own gear. If you've ever tried this and failed, well, welcome to the club. We're going to deal with self-reliance, local first tooling, and today's episode is all going to be about repurposing old machines. We're also going to dig into basic file processes, file networking for a local or offline style setup in the home lab. And then we'll finish it off with trivia picks from the recent LinuxFest Northwest. So buckle up, here we go. Want to thank the sponsor of this podcast, which is Ameridroid.com. Ameridroid is the United States, Northern California-based distributor of single-board computers, especially Odroids from Hardkernel, and official partner of Nabukasa and Home Assistant Hardware. They offer global shipping, and they have friendly customer service. You can call them on the phone. They're awesome people, super nice. They'll help you out. It's definitely an advantage to order from them versus ordering directly from overseas and Hardkernel and such. And they're just an all-around great provider. Can't recommend them enough. Thank you for sponsoring the show. You can use Linuxprepper at checkout or use the referral link. So what is a battle station? A battle station really is just a cool term people have put online for a gaming type setup. In addition to an office, it's like you have some comfortable gaming setup with an ergonomic chair set up to, kick butt in an online game. So we're going to take the same concept, but adapt it to the Linuxprepper style user and administrator, which means instead of going for something fancy, we're going to actually just reappropriate the gear we already have to make sure that it's working in a foundational way that supports us in getting work done and assumes that we'll run into problems and snafus. So my focus with this has been old hardware and old software. We're going to break our battle station segment into 4 sections. First, we're going to talk about graphics and gaming performance, 32-bit specifically. Then we'll jump into Pipewire. We'll follow that up with managing memory between 16 and 1 gigabytes on a machine. And we're going to end it off with local file networking between 2 machines as the basis of a minimalist home lab before trivia. And I want to give a caveat that I got really deep in the weeds on this over the last 6 months. And there's so much material, so I'm going to try to keep this really focused. And that way we can break it into different chunks, different episodes. Do send me your thoughts, because this is the longest deep dive I've ever had. And I hope you enjoy this condensed version of what was previously 2 hours. Battle station, gaming setup, usually with a computer, monitor, some gaming peripherals designed for optimal performance, right, and for your own comfort. So in this case, we're going to build out our own little Linuxprepper battle station. 2 of them in this case, with the assumption that at least one is going to break down. I've already lost 2 laptops. What's another one, So 1's not good enough. We're going for 2. This means anything I'm running on one machine, I have to be able to run on the other. And that means the directories had to be managed equally across the machines. So if I work on machine A and I work on something else on machine B, it's not going to mess me up. I've got a system I can understand, and that's what we're delving into today. We're going beyond the first steps, and now we're going into the next steps, which is making machines we can actually use. Quick recap of what happened with that fancy laptop. It was the fact that I had a new laptop, but it had broken. I couldn't get access to the BIOS. The screen was damaged. So that inspired me to crack open my discarded gear drawer. I call it my cabinet of shame. And I also have a steamer trunk of the same, of old projects and old parts. So I dug into that, and you can see in the forum I have a detailed technical breakdown of what I used. But the basic gist is 2 Intel NUC thin client computers. One has a solitary USB 3 port. It's an i5 that I'd upgraded to 16 gigabytes of RAM. And the other one has a USB 2.0 port. And I dug around and I was able to get it up to 12 gigabytes of RAM from the trunk. And I have 2 matching 24-inch monitors. So I put one on each. I have a keyboard, my Dell, which I've mentioned before. It's just an old Dell. You can get it for a few bucks. And then I got some mice. They sell for about $20, and they're absolutely amazing. I have a link to them in the forum. And I have 2 simple desks. I found some TP-Link Wi-Fi adapters and Bluetooth adapters for USB 3. Since USB falls back to 2 or 3, I figured that would work. You'll remember I only had one solitary USB 3 on one and some USB 2 on the other. That means in order to use devices, I was going to need to start chaining together USB devices. That's what I need. What I ended up doing was I got powered hubs. And this is something that I played with in the past, but I decided to buy quality powered hubs like 10-port USB individual on-off, high amperage. I think they're 5 amp. Because of backwards compatibility, even USB 2 works totally fine with a USB 3 powered hub on an Intel NUC. You just want it to work, and the speed is less important. I've used it successfully to run the mouse, keyboard, Wi-Fi adapter, Bluetooth adapters, video capture devices, an external USB monitor, small projector. Everything is run without issue. I haven't had a single device that didn't work, which is a great testament to how well supported devices are these days. And honestly, it's a good enough scenario. So the main thing that I noticed to get those machines upright is to go to wired. So running gigabit wired between them makes the biggest difference. But as you'll see, it's not a deal breaker. So what do I actually need for my Battlestation? Personally, I need a USB microphone, which means I got one on both. I need headphones. I got them on both. I need some pen and paper at both. And then I need some kind of chair and some tea. So I've got my desk together. I got my Battlestations together. Then it was just a matter of getting my systems up to date, running Ubuntu. I took the Ubuntu LTSs, which were an LTS behind or 2 LTSs behind. I got those up to date. I'd already moved all of my data into cold storage in the past, so I updated those backup images and then updated my systems. And in general, it was a pretty seamless process. I'm now running KDE Plasma on both. And what I realized on these older pieces of hardware, they have i9-15 Intel graphics stacks inside, which is not powerful and not good. I ran into a lot of issues related to that. So what I would actually recommend on older hardware like this, even though it's an i3 or an i5, I would dump KDE and I would move to LXQT, which is open box based, or you could use XFCE, or you could use i3 if you were open to tiling window manager. All of those would work really well. So yes, in running these, you are literally going back to an X-based system. Hello, X, my old friend. But it's going to run better. So you will get better performance by moving back to X instead of staying on Wayland. It's worth considering on old hardware. And there's also those minimal like anti-X type projects and MX Linux that you can run as well. You still have some support in 32-bit land, but you do have to be careful. The underlying dependencies are breaking. Multi-architecture support for Debian is still available. Despite 32-bit dropping off overall, you can still make it happen, as well as with Arch and Void Linux. But there are still 32-bit options out there. All of it is trying to be put out to pasture. Good news is there is still support. I've been focusing on devices that I can run 64-bit on. But something that I want to mention in terms of 32-bit is I've been struggling a lot with running 32-bit software. The libraries and dependencies of 32-bit are problematic in their support. Even in reinstalling X, reinstalling multi-architecture and 32-bit support, I find myself having to dig back through, like, for example, the Debian repositories, trying to find these dependencies that have changed. Whereas I thought that I would just be able to run software 64 or 32-bit from 12 to 15 years ago that I personally own that's DRM free. I've found a lot of problems with it. And a lot of that comes back to, gaming, right? Gaming type tools. But I'm really surprised to see that overall platform support for software you would imagine would work does not. This is one place. Windows itself crushes Linux. Windows still offers that 32-bit support, just like Wine gives you that 32-bit support. If you want to run 32-bit software in Linux, it's painful on modern operating systems. Even tools like I was able to run without issue in the last, say, 5 years is performing worse in 2026 than it was at that time. That's frustrating. And obviously repositories have changed and packages have changed, but I see this as a limitation of Linux itself in terms of its 32-bit support and support for legacy code, which is just not as good as you would imagine. So we keep chasing the shiny and new, but the truth is the old code that you have, it doesn't mean that it's aging well. And you might be surprised when you try to run it and you run into difficulties with these old applications. I realize we're really focused on gaming right now, but it's important because if we step away from that 32-bit and old systems and we come back to these Intel NUCs with these Intel i915 stacks from, 12 years ago, whatever, and you look at those in terms of, say, just use Steam. Well, the problem is that Steam itself and Proton technology is not supporting these old titles either. That's what's recommended, is like, oh, use Proton. Well, guess what? Proton dropped support for the Intel graphics stack back around 7. So you have to install old versions and pray that they work. And all these things were working perfectly in the past. Like in the last couple years, you could run any of these titles and now all of it's totally broken. So that's just not good. And this is not even about Windows games. We're talking about Linux native games that are broken. And then you're trying to run them through Proton, which is also not supporting the graphics stacks because they want to support the new graphics stacks of Vulkan, whatever. Ugh, it's just broken all over the place. It's not good. So this is not good. If you bought a game in the past, you expect that you can use it. And apparently that is not the case. And it's very frustrating. And then you're back in the weeds, like it's 20 years ago, and you're trying to fix this dependency and that dependency, and you're in depackage on the command line. It's like, dude, what happened? What happened to just being able to have stuff run, and you assumed it would still run back in the, in the future? Maybe this incessant need to throw away the old for the new at all times is holding us back. Maybe that's holding us back. Something to think about. There is some good news. If you were like, man, I really want to run a modern game, well, I have an option for you that is really exciting. The Love 2D engine is coded in C++ and uses Lua throughout. It's ultra light and can still be built for 32-bit, which means you can also rebuild games packaged through Steam for app images and run them on a 32-bit compiled engine known as Love. So what you can do is you can purchase a game on Steam, like Balatro, you unpackage it, take that Love file, and run it through your 32-bit compiled version of the game engine. And Bob's your uncle, you're able to run these games on a 32-bit system right now. And that is the power of a free and open engine. Specific notes for that will be included in the show notes if you want to jump on the forum and try doing this yourself. As a quick shout out to these Love 2D coded games that you can still run on 32-bit, not to mention the Intel graphics stack, be sure to check out one is Moonring, created by the creator of Fable. It's an old school Ultima style RPG. You can get it for free, so you should be able to get the app image directly off itch and build it for 32-bit or run it on your local system. There's also Balatro, which is a super famous card game right now. It's a major seller where you basically create game-breaking hands of cards. And there's Arco, which is a Meso-American turn-based fighting game. And I highly recommend checking out Arco. It's worth noting the developer explicitly mentioned most likely will never make another game of this kind a passion project because it hasn't sold well, even though it's been critically acclaimed. And you can play the demo of the game. I tried it out on Steam. It's super fun. Great pixel art. Highly recommend checking out Arco and Balatro and Moonring. As we wrap up this section talking about the more visual side of older systems, do keep in mind that if you're running headless, the situation looks far, far better, especially because of Go and Rust. Go and Rust, all these applications, I found over 100 great tools that we recommend all the time on all these different podcasts, right? Like Uptime, Kuma, all these different tools. They're all written in Go and Rust, which means you can use them on 32-bit. Awesome. They run on 32-bit, they run on 64-bit, and they're perfect for running at home on low systems, like on very low RAM, 1 gigabyte systems. You could run multiple of these applications, reverse proxy, DNS, DHCP, and there's a lot of options out there. So in that way, 32-bit hardware is still extremely usable. But let's jump back into the desktop portion of things again, but this time let's focus on audio. On the audio front of things, I've had a fantastic experience. Back in February, I started looking into my options for Pipewire, for audio interfaces, multiple of them, managing them on this local machine, because that was one of my goals, right, with getting started in this whole project. And one of the things I found is that Pipewire support for audio on Linux is amazing. It's fantastic. And I've had such a good experience. If you look at the forum post, you can see the crazy picture of all the stuff routed. What you get is all your different USB connections, your Bluetooth connections, plug them all in. Like me, you might be wondering, well, how do I access an audio device? For example, in Audacity or in any audio recording tool, Reaper. How do I run this input to this output? I'm confused. And I was struggling with that. There's 3 different tools that are really important. And there's more, but this is a good start. Number 1, Wireplumber. Wireplumber is the session and policy manager for the Pipewire API. Wireplumber is the actual configuration files that are being managed for the audio interface. So you can create Wireplumber configs, and that'll get you covered. It gets better. There is also the QPWGraph, which is a GUI tool that shows your audio assignments and video in real time and MIDI. So definitely save your existing configuration because it's really easy to screw things up when you have all the patch points. Like an old telephone operator, you can just wire anything into anything. It's so fun. And it's all visual. So QPWGraph, if for some reason, for example, you don't hear something like in your headphones and say you're playing music on your speakers while you're recording, you could at any time open up QPWGraph and say either I want to take the speaker output, or let's say you're playing from Firefox, I want to take the Firefox output and route either to the headphones. And then it's done. It works. And you can do it on the left ear or the right ear in stereo. You can split it up however you want. Very, very cool. I would say I was confused when I was trying to do things directly in different applications, as well as I was confused because I'm so used to ALSA Mixer and Pulse Audio. Pipewire is a drop-in replacement for these applications, but for configuring Pipewire, you'll want to do it directly in Wireplumber or with something like QPWGraph. And for Jack assignments, that's PW-Jack. That'll manage Jack assignments, which is like pro audio-y stuff. Here's my note on Jack. You don't actually start a Jack server when you're using Pipewire, as Pipewire emulates Jack. Instead, you will configure the application to use Jack, which will then connect through Pipewire without needing the separate Jack server. Even with the basic wiring in Wireplumber, it gets you 95% of the way there. I am happy to say once I figured out this basic routing in Pipewire, everything has been awesome ever since, and I have been able to run 4, 5, 6, 8 devices, and everything has been cherry. So I highly recommend learning about Pipewire configuration. It rules. If you enjoy hearing about pro audio and all this kind of fun DIY approaches, I'm going to include a bonus episode with this one on Aphex Twin, the electronic pioneer, who has made an entire 40-year career out of using any and every imaginable tool, be it the command line, hardware synths, whatever, to make crazy amazing music for years. And it just, every tool is pushed to the absolute limit. And if that interests you, you can check out my dedicated episode to Aphex Twin, who would use the absolute ever-loving everything out of tools like Pipewire. Ways to support the show. The best thing you can do to support this show is to share it with somebody else. If you know anybody that would like this show, please share it with them. The second best thing you can do is let me know. You can send me an email, podcast@livingcartoon.org. You can drop in the matrix or send me a message if you like the show. Seriously, this show is so small and it actually does inspire me to want to continue. And if this show interests you, let me know, because I have over 15 pages of notes in regards to the show. Oh, hello, Carl. If you can hear him, that's my cat. Back to the episode. I would be remiss not to mention the ram-shaped elephant in the room, which is, of course, memory. Memory's crazy, memory is limited, so let's take a moment to specifically address memory, no pun intended. Related to everything here, right, is memory. Memory prices, disk prices being insane. So what I'm saying is that having low memory on a computer inherently means you're going to hit the limits of that computer quickly. And I definitely found that, right? I'm not gonna lie in any way. I hit the limits of memory immediately in terms of swap. And so what I dug into a lot is Zram. And Zram really helped with performance, with some tuning. And I just want to read what this person posted to Reddit, and I'll link it because it's useful. Zram is a Linux kernel module that creates a swap space in RAM, as opposed to having it on your disk. Swap partitions on a hard drive or an SSD are slow. And I found this. I hit my limits in them because of browsers. The web browser is the problem, right? A lot of the time. But this results in stuttering where the machine decides to start using swap space. Zram is an alternative to swap space that compresses memory before storing it in a designated space in RAM. This means you get more efficient use of the RAM, as your system will now compress files in memory when needed. In using Zram, I did find notable improvement in my daily browsing experience. And I'm not talking about any kind of browser level manipulation of things, just in terms of the computer itself and allocating Zram to performance. So Zram is kernel supported on all the major Linux distributions, but it doesn't mean it's enabled by default. For me, I had to install the Zram-tools package. And from there, I was able to set up a Zram partition. That part was easy, and it did work really well. I'm going to pull up my notes and say exactly what I did. Let me look. All right, let's go back through my system deconfiguration of Zram swap. Systems with 12 gigabytes of RAM. How systems behave. 12 gigabytes of RAM, enough for basic use. But once you're adding KDE Plasma, gaming, web browsers, then I'm running out of memory, which is exactly what's happening. So let's talk about the role of Zram in 12 gigabytes of RAM system. It's absolutely critical. It acts as a buffer before I jump into that disk swap. And what it does is it prevents KDE Plasma itself from freezing, because that's what was happening to me with 12 gigabytes of RAM. It's like you watch a YouTube video, browse the internet, and be doing something, and the computer just seizes up. And I'm like, ugh. So what it does is it's going to grant me an additional 4 or 6 gigabytes of compressed RAM. That's going to help keep the system from being responsive instead of it just like locking up. Because once it locks up, there's like nothing I can do, It's like a frozen robot. And I'm just like, ah. So that's not good. It's giving me a little bit of a safety net, a little bit of a little space to work with. It takes some of the pressure off. So it did help, and it helped on both NUC computers. So let's talk about my 16 gigabyte RAM system. So 16 gigabytes obviously is a little bit more comfort. I can do more multitasking, but Zram in this case, still important. It's giving me like extra 6 gigs compressed RAM, which is again preventing KDE Plasma in this case from locking up. In case browser spikes take up all my memory, because browser tabs themselves are taking up so many hundreds of megs or 75 megs at minimum per tab, and things just add up quickly. So swap's still there, but it's just rarely used as the intention. So in this case, Zram is about half the size of the available RAM. Swap file is a quarter of the size. And then I'm taking it's called Swappiness. I'm taking my Swappiness down, and I'm using a program called Early Out of Memory, and I am running that. Let's talk a little bit about Early Out of Memory. All right, this is from the project GitHub page. What is Early Out of Memory? So Early Out of Memory wants to be simple and solid. It is written in pure C. It has no dependencies. It is an extensive test suite, unit and integration tests, which is written in, who knew? Go. Early Out of Memory checks the amount of available memory and free swap up to 10 times a second. By default, if both are below 10%, it will kill the largest process, whatever has the highest out of memory score. The reason this matters is because if your computer's about to seize up, it's better to kill the process than to kill your entire computer. I'm specifically talking about the web browser. So we're just giving ourselves multiple levels between Zram, swap, and the out-of-memory daemon to prevent losing everything. And, okay, why not trigger the kernel out-of-memory killer instead? You can make early out-of-memory trigger the kernel out-of-memory killer by passing along a flag. However, in some Linux kernels, triggering the kernel out-of-memory killer does not work. That is, it may only free some graphic memory that will be allocated again and not actually kill that process. You can see how this looks on machines such as Intel integrated graphics. which is what I'm running. How much memory does early out of memory use? About 2 megabytes, though only 220 kilobits is private memory. The rest is a libc library that is shared with other processes. So I have had no problem running early out of memory on my computers. It hasn't caused me any kind of trouble, but it's really once I did that Zram, in addition to this, that I've had much better performance. And this is a good little setup. Zram, swap, reduced swappiness, and getting out of memory Daemon or similar in case something just eats through all your RAM, which browsers are wont to do. You just got to protect yourself from the whole system seizing up. And let's say while we're talking about this, that you're like, what is this whole swappiness thing? And why does that matter? Before we jump to this out of memory Daemon killing things, what's the deal with swappiness? So swappiness is controlling when the kernel starts moving the memory out of RAM. On a system where now I'm running Zram and swap, that means it's affecting me on 2 layers, right? First, you have the fast compressed Zram, which is used before swap. So swappiness doesn't change that. Then you have the disk swap, which is slower. That's where swappiness matters, right? At a rating that I have around 20, it means I want you to avoid using the disk swap for as long as possible because it's slow and limited. That means on my 12 gigabit system and even on 16, I'm going to go through memory pressure, and swappiness is going to determine how gracefully I'm working through my memory. My goal is just to keep the system responsive. And what I'm saying is if swappiness does not need to occur, I'm discouraging it. So how does early out of memory interact with the Zram, right? Early out of memory is this watchdog. It's preventing the system from freezing once the memory becomes exhausted. So it's monitoring the RAM, monitoring the swap. And once things fall below this threshold of so many percentage points, single digit, 10%, then the largest memory hogs start getting killed off. This is to protect KDE Plasma and the system itself from locking up. And this is before the kernel's out of memory killer, like we already mentioned. So why does this matter? It's because KDE Plasma does freeze on me. If I exhaust the RAM with the browser, my system locks up. At least I'm able to kill these runaway processes before the system locks up. And with Zram, I get a little more safety bandwidth time before I have to kill those processes. If you had a larger amount of RAM, then this doesn't really matter anymore. Once you have 32 gigabytes, you just got a lot to work with. But in this case, I don't. And let's take a quick moment to talk about, does any of this matter when you have extremely limited RAM? Okay, so when dealing with 8 gigabytes of RAM, it seems like so far for me, things stay pretty much the same. Zram, roughly half of the actual RAM. Swap, about a quarter of that 8 gigabytes. And really all we're trying to do is prevent freezes from when the browser spikes. The early out of memory, still recommend it. 8 gigabytes still obviously is enough that your system can work. You just don't want it to die. Let's drop down into the 4 gigabyte of RAM. Let's say that now we're using, XFCE or something like that. So now it's just we got to keep the system responsive, period. So we're still doing roughly the same ratios. 2 gigabytes ZRAM, so half of it. Roughly the same in swap. A higher degree of swappiness because it's just going to happen. And we're still using early out of memory. And then in this case, we just want to try to avoid these heavy services. So if you only have limited RAM, obviously, you don't want to be running, snaps, containers, any kind of preloading thing or heavy workloads because it's not going to work. It's just total borderline, right? Because even say XFCE is going to use several hundred megabytes just to run. So Zram will still give you some space. Swap will still help with crashes, and early out of memory will still help with systems locking up. But you just have to keep things very, very limited, obviously. And now we're getting into a space where, the distributions themselves don't recommend having this amount of memory or even close to it. But what about if we drop to 2 gigabytes of RAM? So if we get down to 2 gigabytes of RAM, now we're just trying to minimize the actual amount of RAM that's being used and keep the system running. So you could still do Zram. Now you're basically doing half again. Swap file half. High swappiness because you're going to use it all the time. Still using out of memory. But all notification, background services, everything we don't need, we're disabling it, right? No more indexing. No more extra anything. Extremely tight. So it's like a VPS style system now. And if you're doing desktop, you're just keeping it light. So you could use like XFCE or something. It's going to be slow. It's not going to be good. And then your browser, obviously, you just got to be careful with Firefox and things like that. We're not going to go into that, but you could really tweak it, obviously, in order to not multitask so hard. Once we drop into the 1 GB RAM territory, now we're talking, obviously, like a headless server. We're just running a terminal. That's what I am anyway. At that point, you could still use Zram. You could still use swap with high swappiness, but you just want to disable all extra services like very aggressively. So at 1 GB of RAM, you're just like anything you don't need, you're just taking off because you're just hitting the threshold all the time, right? And Zram and swap might just keep your system running, period. But I think the main thing to me is like, you just don't run anything extra. At least I don't. So even compose for me on a 1 GB system, I just don't use it. I mean, I'll just replace, I'll do that on a fancier machine or whatever. But I just hope this gives some ideas of RAM usage. And please write into the show if you have more ideas of how to maximize RAM. But I did find that this did really help with performance for myself. And once I get into a headless, bare minimum 1 GB, I more just worry about only running the literal thing that I want to run, and I don't run anything else. That's the honest truth. All right, now that we've jumped through all these concerns and all these whatevers, what actually are we going to run on these devices? I'm glad you asked. This is something I'm very excited about. Touching back from the last episode, having, basic, a recursive little DNS for faster lookups, and having these devices with limited RAM, but basic performance. Well, obviously, you're going to want, say, these two little NUC computers to communicate together. No matter how much RAM or how much performance they have, you want to get basic tooling done. This is exciting because the tooling we're going to talk about is the same tooling that's been powering Linux and Unix machines for decades. Let's jump in on that. So one thing you can do, obviously, is you can take a device, an old Pi 3, which a listener did, as part of the DURP, that's the DIY Unfinished Resurrection Project Challenge, to work on something that you've been putting off. They took an old Pi 3 and they installed a service called Octoprint onto it, just to manage a 3D printer in place of an SD card as a way to send files over Wi-Fi. And it previously had been used on a Pi 5, but they downgraded to the Pi 3 because it has full-size USB ports, it has wired Ethernet, and it gets the job done. So it worked well enough, right? So like that's an option, is you have a sort of form-fit application you can run. But let's go even before that, and let's just say you're connected to this machine. Well, the first thing you're basically going to want to do with any machine is you're going to want to move a file or a folder around. Let's focus on the terminal. You're going to use the GNU Core Utils, something like the cpmv command, copy move. You copy a directory from one location to the other, right? I want to copy because I still want to leave my original copy where it is. In case anything's wrong, I have it in two places. Now let's extend that to these two machines. They're on the same network, so I connect them using good old SSH. I make an SSH connection between the machines to move files, but I'm like, well, that doesn't really make sense. I'll just use the SCP command. In this case, SCP literally means copy over SSH. Who are we? We are somebody that just needs to send something to a place. One way, we're going to use the SCP command to send from where our directory is right now to user at remote directory and send the file or folder. SCP is equally useful to pull in reverse. So you can SCP to your local directory from remote user at host from X directory that you remember, and that'll pull from the remote machine to your local machine without having to do anything else. It's pretty amazing. So you can send or receive files using SCP. Very, very useful. That works. I do that all the time to send myself something between machines. And it works. But it's also limited. Because think about it. You're moving a file or a folder. And right away, you're like, even though I'm just sending this off somewhere, I want to maintain my timestamps. I want to do a little checksumming to make sure that this process is working properly. I want to make sure that the ownership and all these things don't change. Maybe I'm making changes on your behalf as the administrator, and I don't want you to know about it because it's a network drive or something. So in that case, I'm not going to use the scp command anymore. Now I'm going to use rsync. And rsync has been around for 29 years. It is an unbelievable tool. It is the basis of all modern backups, more or less. So what you're doing with rsync is you're doing the same concept. You're moving a file from one place to the other, a directory of files. But now you have really comprehensive control over what rsync does. So you can still use scp. This is all foundational. But with rsync, I want to move this series of directories to this new machine, but I'm worried I'm going to screw the command up. So I'm going to do a dry run. And you can literally -- dry run or -n, and you can actually see what will happen without taking action. So this makes just for the dry run capabilities alone in the analysis. Rsync is an amazing tool. And of course it can be run through SSH or locally or to an external disk or for backups. Rsync, killer in a one-way fashion. So if you want to have a more bi-directional approach to rsync, because now it's like, okay, now I'm not doing the one way anymore. You might use a tool like Unison. Unison has been around for 25 years. It is built off of rsync. But rsync is designed to be run on 2 machines, which is perfect for me. I have Unison set up. Why? Because I have these audio recordings that I'm moving back and forth. Obviously, I could use some other tool, but it doesn't make sense because these files are pretty large. I'm working with 40 gigabytes worth of audio files. My Nextcloud is 5 gigabytes. Google Drive is 15 gigs? I don't need any of that cloud stuff though. I can do this machine to machine. So what Unison does is it does what I was doing before with scp and rsync. It's actually being run on the 2 machines. When you call it only, it's not real time. Based on the state of the directory you've named, both machines are looking at that state and they're adjusting accordingly to keep perfect validation across both machines. So it's like this directory is what it's supposed to be on machine A and machine B. And even if one of those Unison links goes offline, when they come back up, they'll sort it out. So you can be making changes and it'll get resolved. That's all Unison does. It doesn't do any extra special anything. It just keeps this directory as perfect as possible. And you can do a hub and spoke approach and run multiple iterations of Unison. But Unison's not designed to be run on top of itself. So it's going to stay at that 2 machine limit. It's not designed to work it out between 4 machines or 6 machines or 8 machines on the same directory. No. It's not designed for conflict management. It's just designed to keep this directory that you've defined perfect between 2 machines. If you want something that scales up beyond Unison, keep in mind the tools we're talking about, these will run on potatoes. I'm talking I ran these on a 400 megahertz box that I have at my house. So all these tools run great on anything that can run. So if you can't run SSH, you basically can't use the computer for networking. And scp, rsync, and even Unison will get you there. But if you want to scale up, that means you're going to obviously be using more resources. But now we go to another excellent tool which runs in real time. And no, that tool is not Nextcloud. It's not any sort of cloud service. We could use cloud services, but that's not the point of this episode. And even if we did, there's a big caveat with Nextcloud, which is that it screws stuff up. And I've been using Nextcloud for years. I use it offline. Like I'll run, for example, it only on Wi-Fi. I have the Nextcloud desktop app on at this moment, but usually I just have it turned off on these machines because I don't want to use the RAM, right? And in this case, I don't need to move the data to an additional server. I don't need to use WebDAV, and I don't fully trust WebDAV because I do have issues with these kind of database files or these large chunky directories when all I'm trying to do is just migrate my changes from machine to machine. In that case, I personally don't want to use Nextcloud, or I don't trust it as much as this next tool, which does not require a server. And that would be Syncthing, right? We're going beyond KD Connect because that doesn't scale in this case. So that's a way to send things between a file, folder on your phone and your computer or whatever. But yeah, we're moving beyond that. Syncthing can be used on as many devices as you want. What's cool is you actually have a global look at each node at each device on the system, right? And they're running in a peer-to-peer fashion. It can scale up as much as you want. And what happens is every single node or client is aware of each other, even if no changes are being made. So say you're running 5 Syncthings and they're all working together. They are aware of each other. So they know, for example, oh, node 5 is offline. Node 3 has gone offline in the last hour. And that means that changes can be propagated in a peer-to-peer fashion. There's not a central node. And the nodes will help each other make this sync possible. So Syncthing is a super useful tool, and I have found that it works well in a similar fashion to Unison, where I turn it on when I need it, I turn it off when I don't need it. And I think if the only goal is to keep that folder synchronized, obviously you should go back to Unison between 2 machines. But if you want to have more flexibility with phone clients and stuff, then Syncthing is a solid bet. Even with like 2 gigabytes of RAM or whatever on a box, I say minimum. Syncthing is good. Just use it when you want it. And I would use Syncthing over Nextcloud because you just don't need the server aspect. I just need to move the folders back and forth. I can do it over VPN, whatever. Syncthing will make it happen. No tool's perfect, but these are always tools you can fall back on. And because I'm a guy that comes especially from Nextcloud, even Nextcloud themselves have recommended Syncthing for just moving large data sets and rsync, because these tools work. And this avoids having to do the whole sync up to the server, sync down from the server to your device. You're just moving device to device. And plus you have things like doing deltas, which is looking for what changed, and you get functionality with compression, whether it's with Syncthing or Rsync. So this is good. And I think we'll leave it there for this episode as far as these tools. But these are like the foundational tools that you can use to build yourself a basic home lab. So you're moving folders, you know where they are, and now we're starting to do backups, right? Using one-way synchronization. Really what you're doing is you're making a backup. You're moving your data to another location. Maybe you're doing some level of compression or encryption. And I'd like to get into that in a future episode. But I'll give you one more tool because you can run it on a low-end machine, and that is Rclone. Once again, both of these tools are coded in Go. So Rclone is a command line tool that is inspired directly by Rsync, but it's for cloud providers. You can use Rclone as a way to access a remote cloud provider like Google Cloud, Google Drive, Dropbox, Nextcloud WebDAV, S3, whatever. You can connect to a service provider, a backup service, which people do all the time. Using Rclone, you'll be able to have a mount, like a fuse style mount of a remote location that otherwise does not support it, in order to send Rsync-like directories to that location or pull in either direction. So it's not designed for real-time usage. It's inherently a bit flaky to mount these providers that otherwise do not support this technology. It's, I wouldn't fully trust it. I know people do, but I would be wary. But if your goal is to get your data out of Dropbox or whatever, Rclone will make it happen. And if you limit the threading and the amount of transfers and stuff, and you just really lock that down on the configuration level, because it's a command line tool, you can run it on an extremely minimal machine, and Rclone will work. Anyway, that's enough of these tools for this time. Something you'll notice from this sort of experimentation and local first tooling, like we're talking about, is really what you have is you just have a home lab. That's what this is, right? This is a home lab setup. Every one of these tools is a valid tool that can be used professionally, that you can fall back to. Even if you're using other things, you can always use this tooling in addition. And that's what people do. So congratulations. If you're running any of these tools at home, you're running a home lab. Try using SSH to make a connection. Try using SCP to copy a file. Try using Rsync to verify that file. You could try using Unison between multiple machines to keep a file in sync, or you can make backups with Rsync. And these are all valid tools that you can use forever. And you have a basic kind of peer-to-peer connection between your machines, whether it's local or then through a VPN. And that's what I'm working towards, is giving you the tooling to have a rock solid, awesome setup that you actually understand. And we're building up, right? We're building up towards playing with containers and playing with these other things. But either way, I think we're addressing the biggest concern that people have in regards to things like containers, which is how well do you actually understand a tool that you're using and how well is it actually working for you? So that's where we're coming from, is we're going to understand the tool. And that way, however you've set it up, we don't care. But the point is you at least know what it's doing. And it's worth taking the moment to figure out as we continue building up into more and more workflows beyond, say, now taking a machine and a device and growing that to a couple machines, couple devices, and beyond. I think we'll close this thing out by going over some of the trivia winners from the recent LinuxFest Northwest, which will be also dropped as a bonus to this, talking about that experience. It was a lot of fun. But let's go into some of the named projects to end out this episode that people who played trivia named off. I told them they can name any project they want, and I will share it on the show, and let's talk about those. So trivia was a mix this time of questions which people found quite challenging in regards to Linux and open source trivia, followed by a practical bonus round of free and open tooling that people have actually done in their daily lives, whether or not they've done it as a point. So top score was Romeo with total of 30 points, 22 in the main round, 8 in the bonus. Romeo named off Ubuntu. Romeo also gave a talk on Ubuntu. LinuxFest Northwest called Ubuntu Without Handlebars. We'll do a link to the room. You can check out that talk if you want. Recording for it available on YouTube. Trailing immediately behind, right on the shoulder of Romeo by a single point, was Matthias of Victoria Metrics. Victoria Metrics being a drop-in replacement for Prometheus Grafana. And that was 21 points plus 8 in the bonus, so 29. It was very close. The other score, very interesting, which got 10 on the daily application of tooling in their life, was Salt, who named Siegel. Siegel Conference at the University of Washington is currently accepting talks if you want to submit for that. Let's keep going. From there, we had the GNU Boot project. We also had Meshtastic, the communication decentralized network. Pi Club, which is based out of Washington. Slackware, the gentleman for that said he runs a Slackware mirror with his father, and they run all of their software through the mirror locally and even offline. That's interesting. We also have the Triton Data Center, WWU, that's Western Washington University, FurryTail, Noster, Fusion PBX, Nextcloud, another Pi Cloud, Clonezilla, TakeTheStone.xyz, Nixbook, LibraPhone, OpenStreetMaps, BooKitty, Zipline Recruiters. And yeah, if you want to check out any of those, feel free. A big thank you to everyone who participated in the trivia, and also thank you to LinuxFest Northwest for letting me be there at a table. I had a great time, and I recommend anyone interested consider being a part of Siegel this fall. And check out the link if you want to submit as a speaker to participate in Siegel, all about GNU and FOSS. Coming up in the next episode, we'll be talking about monitoring of services, making sure things are running, making sure that the networking is running smoothly, because once it's actually something's online, how do we know? So we'll dig into that next episode. We'll also touch base on a little more on the LinuxFest Northwest Conference, what happened there, what you can expect at Siegel. And it'll be a good time. If you have any thoughts or comments, do send them into the show. Otherwise, thank you so much for tuning in to Linuxprepper, and have a wonderful day. Bye.